Record the screen. Share the screen. All right. Hi. Okay, so 3.1 is complex numbers. So long ago, mathematicians would get bored, and whenever they didn't know something, they would just make it up. We're really good storytellers. And this is basically where complex numbers came from, was the need to be able to take the square root of negative numbers. So they created a whole new number system. So when you draw a real number line, your x-axis and your y-axis here, this is just real numbers. However, if you ever needed to take the square root of a negative, then the complex numbers are born. And we define the square root of -1 to be I. And what that means is I squared is -1. So I is the symbol we use. It is not a real number. It is under the realm of complex numbers.
Hello.
Do you have orange chicken?
I'll take an orange chicken. Who else wants something? Someone's ordering for us.
Hello.
Seems like that. Oh. Alright, good. I really want a General Tso's. I really don't like orange chicken. Anyways, that's all being recorded, by the way. I'm not deleting that out because that's hilarious. Anyways, we define I to be the square root of -1. And we're going to learn in this section what you can do with I in terms of how do you add numbers, subtract and multiply, divide complex numbers. To be very honest, what I already have on the board is all you really need. But going forward in trigonometry, you're going to have a whole, I think, 1 or 2 sections related to complex numbers. If you're going into electrical engineering, believe it or not, these guys are very, very important. So there's that. So we're going to start off with what's considered the algebra of complex numbers. Two comments. Comment 1. I don't know if you heard today, but Eastern Campus got closed due to a gas leak. So my class got canceled, which meant I couldn't grab my lecture notes. So I'm totally going off the cuff here. If I seem semi-professional, I'll take it because I don't want to ever be professional. Comment 2, anytime in mathematics you hear the algebra of, it means, what does it mean to add, subtract, multiply, and divide is usually what that refers to. We used to teach matrices, hardcore matrices in this class. So you would do the algebra of matrices. We'll have the algebra of, we already had the algebra of functions in chapter 2. All that good stuff. So we first start off with adding and subtracting. And this is where I really wish I had my notes because I forgot to say something earlier, but we'll make it work. And a complex number is going to be of the format a plus bi, where a and b are real numbers. They will all have that format. A is called the real part, and the B, just the B, is called the complex part. So when you are adding complex numbers, so if we had another complex number there called C plus DI, all you do is you add the real parts and you add the complex parts. In other words, you just combine like terms. So for example, if you had 5 plus 3i plus negative 7 plus 2i, first off, are those parentheses necessary for addition?
No.
No. And here's the deal. The mistake students make with this, honestly, is notational. They see those grouped parentheses and they think FOIL. FOIL means coming from multiplication, not from addition. So don't be confused by the parentheses. For an addition problem, they are not necessary. Well, I should say plus minus 7 is just minus 7 plus 2i. So you just group the real parts. So 5 minus 7 makes negative 2. And group the complex parts. 3i plus 2i makes 5i. That's it. How many of those do you want on your test? I was taking a request. No one said anything. Wait, was that 5? You want 5? Okay. 5,000 it is. Sounds good. And then just with subtraction, the only thing you have to worry about is, double negatives. So if you had negative 7 plus 2i minus the quantity 3 minus 5i, as you might guess, just make sure you distribute that negative through. And then it becomes an addition problem, just combine like terms. So we would have, what, negative 10 plus 7i. And that's it. So that's adding and subtracting. Next up would be multiplying. To multiply, the big thing to remember is that I squared is negative 1. So for instance, and honestly, we can do all of this by example. There's not too much theory going on here. So if we had 3 plus 5i times the quantity 2 minus 3i, well, that's a binomial times a binomial. If you have a binomial times a binomial, what should you do? It rhymes with Lord's first single on her first album.
I'm gonna FOIL it.
Very good. It was Royals. That was the answer. Very good. So if we FOIL, what does first give us?
6.
Good. Outer?
Negative 9i.
Good. Someone else? Inner?
10i.
Yep. And last?
Negative 15i squared.
Excellent. All right. Questions so far? Okay. I squared is negative 1. So negative 15 times negative 1 becomes positive 15. And that positive 15 is now a like term to the 6. So those combine to make 21. And negative 9i plus 10i is I. Also pronounced I, your choice. So the product here would be 21 plus I. And I'm going to hit save real quick because technology He's a goober sometimes. Boop, boop, boop. Okay. Okay. Before we get into division, we have a couple comments to make. One, let's talk about simplification. And this deals with multiplication as well, just in reverse. So remember, the square root of -1 is the same thing as I. So under this definition, the square root of -5 could be written as the square root of 5 times the square root of -1. Square root of 5 does not clean up, it just stays square root of 5. But the square root of -1 is I. So we can say that as square root of 5i. The problem is, just be careful, what I have right there is correct, but just the slight little change, now it's incorrect. The coefficient is the square root of 5, I is on the outside. So if you want to avoid that error, what you can, what you can do is you're allowed to put the I in front. It looks weird because normally it sort of looks like a variable, and we tend to put the number in front of the coefficient in front of the variable, but it's fine. Likewise, you might have a more exciting one. So the square root of -8 is the square root of 8 times the square root of -1. But carefully, how does the square root of 8 clean up?
Wouldn't it be 2 in with the square root of 2 in the inside?
Excellent.
And then the I.
And then you have the I. Very good. 8 is 4 and 2. So square root of 4 becomes 2, and square root of 2 just sticks around, and the square root of -1 becomes I. And same deal, you might put the I before the radical so there's no confusion. Like there's a thunderstorm and the I is scared, so it sneaks in between. That's fine. It happens. Other things with multiplication would be powers of I. But actually, first off, questions so far? All right. Powers of I. Basically, the whole purpose, well, I don't know.
So basically, we choose the, I'm sorry, so basically we choose the smaller number when we do the breaking down.
So basically what you do is when you're breaking down a radical, in this case, since this is a square root, you want to pull out the largest perfect square. So for instance, if this were square root of -32, you would say square root of 32, square root of -1. Well, 4 goes into 32, but that's not the largest perfect square. What's the largest perfect square that goes into 32?
8.
8's a perfect cube. If you were celebrating your quinceañera, you would be celebrating your what birthday? Is that right? I don't know. 16. Say 16. I think that's 16.
16.
Good job, 16. So notice 32 is 16 and 2. 16 is the largest perfect square. So this would be 4 square root of 2i. Now, as a comment, they're not always going to be a 2 here. That was just an easy number to pick for me. It's not to say you couldn't pick 4. You would just have more work later on. So it's better just to pull out the biggest one first. Other questions? Okay. All right. Powers of I refers to what if you raised I to larger and larger powers. So like if I did I to the first, that would just be I. I squared by definition is -1. But what if we wanted I cubed? Well, I cubed is the same thing as I squared times I to the first. Because remember, when you multiply two things of the same base, you add the exponents. Well, I squared is negative 1. I to the first is I. So that multiplies to be negative I. And I to the fourth can be written as I squared times I squared. Well, that's negative 1 times negative 1, which is the same thing as 1. Yep. So far, not too exciting. Cool. We're raising I to different things and we're getting different things. Cool. What if we did I to the fifth? How would you break that down into two parts that we already know about? So like 4 we use 2 and 2, 3 use 2 and 1. 5 we can use
1 and 3.
one more time?
3 and 2.
Yeah, let's try that. I cubed is negative I squared is negative 1. What does this multiply be?
That'll be I.
Yeah, which is the same thing as I to the first. And then if we had I to the sixth, let's do 4 and 2. I to the fourth is 1. I squared is negative 1. Notice we get negative 1, which is the same thing as I squared. So hopefully what you're seeing is it's starting to repeat. So I to the seventh will be the same as I cubed. It'll just be negative I. I to the eighth will be the same as I to the fourth. It'll just be 1. That doesn't happen in the real numbers. When you raise a real number, except for 0 is boring, and 1, so ignoring those two. Oh, and negative 1. Ignoring those three. If you raise a real number to higher and higher powers, the number either gets bigger and bigger or gets smaller and smaller. It doesn't cycle. These guys cycle. Now, why would you need this? More important trig. For our level, not too great. But the idea of having it repeat every 4 is a very, very big mathematics concept. I'm going off script here, so you don't have to write this part down. But it's a big math concept that if you took a math class past calculus called number theory, it's what they discuss there. You've done number theory in your life, you just didn't know it as such. For instance, on a clock, on a 12-hour clock, you are perfectly fine with the idea that 4 hours after 11 a.m. is 3 p.m. Well, that says 11 plus 4 equals 3. And you've dealt with that your whole life, never really questioned it. It's cool. A light switch, you know if you move a light switch twice, it's like you never moved it at all. Well, that says 1 plus 1 is 0. On a traffic signal, you know that if it's currently green, the next color must be yellow. Because that's how it cycles. Green never goes immediately to red. Well, unless there's a very bad accident. Because that's what you're just used to. So this idea of a cycle you've dealt with all your life, there is math behind it. And we don't really get into it too hardcore in this class, but it's a topic for a past calculus topic. Now, as far as what you can do with this on our level, really not much. So, for instance, I don't know, pick a number. Make it exciting.
And
Sure, 410. Good job. That's what I heard. I know that's what you said. So let's suppose we wanted to have 400, I to the 410. Well, we know it has to be one of these answers because it's cyclic. And the trick is to actually use 4. What's the largest multiple of 4 that is less than or equal to 410?
410.
4 doesn't go into 410.
Oh, right.
Unfortunately.
4.
1 less than the cleaning agent that you could use. You guys need to clean your houses more. 409 is a cleaning agent. 1 less than that would be 408. And how many more would we need to make 410?
The I2.
Very good. I raised to a multiple of 4 is always 1. Always, always, always. So this whole thing is 1 times I squared from our list is negative 1. So that says that I to the 410 is negative 1. Hooray! Sort of useless, but that's okay. You could do that now if you really, really wanted to. All right, there was something else. Oh, so one of the big things again with I's is that they're cyclic. They repeat every 4 in this case. We would call that a base 4 system. If you've done any artwork with like Photoshop or Illustrator, you may have heard of hexadecimal. That's a base 16 system. It's the same idea of here there's 4 different symbols. In hexadecimal, there's 16 different symbols. We count in a base 10 system. A light switch is a base 2 system. So that's one of the weird things about I. Another weird thing is that the color is going to randomly change here, I apologize, is neither positive or negative. So in real number land, if a number is to the left of 0, we know it's negative, and if a number is right of 0, we know it's positive. We cannot say that with imaginary numbers. It has no signage, so to speak. So don't assume that negative I must be a negative. That means nothing. And we can actually prove that. And what we're going to do is what's called a proof by contradiction. Now, we are not going to do heavy proofs at all in this class. This is demonstrative purposes only, so don't freak out too much. But the whole idea with a proof by contradiction is you assume the opposite of what you're trying to prove, and then you show there's an error, which meant that your assumption was wrong. So in order to prove that I is not positive, we assume that it's positive, which is the opposite. So that means I is greater than 0. And I'll actually write assume to be very formal, pinky out. So we're going to play with this to show that a mistake is going to happen. So if I is a positive number, let's for funsies multiply both sides by I. Because I'm allowed to multiply an inequality by a non-zero number. And if I is positive, that means it's not 0. Well, what is I times I?
I to the second power.
Very good. And 0 times I is 0. But by definition, I to the second power is negative 1. And notice we have a mistake here. It says that negative 1 is greater than 0. And we know that's not true, which meant that our assumption that I was greater than 0 was wrong. So that says I is not positive. So now let's assume the other side. Let's prove that I is not negative by assuming that I is negative and then creating a mistake or finding an error. And we can do the same thing. We can multiply both sides by I. On the left, we get I squared. But before we do the right-hand side, we just multiplied an inequality by a negative number. What happens? We have to flip the sign. Remember, when you multiply a negative number through an inequality, multiply or divide, the inequality sign changes. And on the right, we get 0. And notice we're going to have the same issue. Sad panda. So I is a number, but it's not positive nor negative. In trigonometry, you learn how to graph complex numbers. We don't do that in this class. All right, so that's adding, subtracting, multiplying. Next up is division. I'm going to switch to the next slide if that's okay. Bink. Boop. Before we talk about division, we have to talk about the conjugate. You probably heard this phrase before when dealing with square roots. It's the same thing for an imaginary number. The conjugate of a plus bi is a minus bi. And the whole purpose of a conjugate, either with like a square root, like 2 plus square root of 3, or in this case 2 plus 3i, is that when you multiply a number by its conjugate, then the radical goes away. So for instance, if we did a plus bi times a minus bi, we will get an expression that no longer has an I. So notice first would give you a squared, outer gives you minus abi, inner gives you plus abi. And be careful of this last part. Last gives you minus, because it's plus minus. B times b makes b squared. I times I makes I squared. Students tend to forget the square on the b. Don't do that, please. Notice the ABI's cancel. I squared is negative 1. So negative b squared times negative 1 makes positive b squared. So when you multiply a complex number by its conjugate, you get an expression that it doesn't have an I anymore. It's a real number in this case. This has a special format that you did not see in intermediate algebra. This is a sum of squares. And just for comparison's sake, when you had, the color's going to change again, a plus bi. Oh no, you didn't see that at all. Erase. Don't write that down yet. Don't write that down. I'm so sorry. Okay. When you had a plus b times a minus b, and you FOILed that, that was a squared minus b squared. Now you have a plus bi times a minus bi, that's a squared plus b squared. So a sum of squares needs imaginary numbers involved. So for example, if you had to factor x squared minus 4, that's a difference of squares, you would say x plus 2 times x minus 2. So that's what that first line is saying. But if you were a crazy person and you wanted to factor x squared plus 4, that would now be x plus 2i, x minus 2i. Oh my gosh. So sum of squares needs imaginary numbers. That could help you. That little shortcut could help you later on in chapter 4. Side note, these two colors combined right here makes me want peanut butter and jelly. That might be my dinner. We'll find out later. Okay. So now on to division. Let's suppose, again, videos for this, so we're going to do a nice and pretty one here. Suppose we had 7 over, I don't know, 2 plus 5i. If you're dividing by a complex number, you're dividing by a radical, so you're technically rationalizing it. And the way you rationalize it would be multiply the numerator and denominator by the conjugate. So the conjugate of 2 plus 5i would be 2 minus 5i. Upstairs, you have a monomial, 7, times a binomial, 2 minus 5i. So you just distribute that through. So 7 times 2 is 14, and 7 times negative 5i is negative 35i. Downstairs, you're multiplying a complex number by its conjugate. You could totally FOIL, or you could use the shortcut. In this case, a would be 2, so 2 squared, plus b would be 5, so 5 squared. So that denominator is 29. However, your answers have to be in the format a plus bi, meaning a real part, operation, imaginary part. So we have to keep them separated. That is what the song from the 90s was about, Ask Your Grandparents. So 14 29ths over 35 29ths I. Okay. Questions on adding, subtracting, multiplying, dividing, powers of I. Awesome. Okay. Before we start 3-2, let me say that thing. So I got this little letter in the mail that says, Mike, you're being summoned for jury duty. Yay! It's the dream of every American. The jury duty starts November 1st. Our midterm is November 2nd. And I live in Lake County, and I got summoned to Cuyahoga County, which means it's a federal court case, which means it's more higher stakes, because usually if you're in your own county, it's something like traffic violation or nothing terrible. Federal court cases are, oh my God, am I going to be in a Netflix special? Oh my gosh, I'm writing a book. I'm already going to write a book. I decided now. Anyways, there is a chance that I might be sequestered, which means I can't come home. And I don't know if I really want to be doing the whole teaching from some hotel room or proctoring your test from some hotel room. I don't know if they'll even allow me to leave because that's what sequestered means. So I don't need an answer today, but what I'm thinking is, in order to avoid that, to move, where's my, it's on that screen, to move the midterm either up a week or back a week. I don't like putting it back because your midterm's already November 1st, and we don't have much time after. And if we did it before, then instead of covering all of chapter 4, it would cover whatever we had done the week prior. Meaning, your midterm would change to be chapter 1.1 through 4.4. So it would shave off 2 sections basically, and it'd move it up a week. And then basically what we have for November 2nd is just the midterm, and the 26th would flop, because even though it's not ideal and I like meeting on Tuesdays, but most likely what I would do is before the jury selection would be, I'd probably make that video on Sunday, just me talking for 3 sections, and just say, hey, go watch it, so it's there, so that way class has occurred and we don't get behind. And then if it's a scenario to where you have questions, you email me. I'll obviously try to get back to you as I can. Or hopefully I'm not selected, because I am planning to go to court with one of my wigs, so they think I'm a crazy person. Unless the court case is about harassment of Irish people, then I'll probably get in. Let's hope not. So there's that. Or people who like David Bowie fans, things like that. I don't know. It could backfire. It's like that episode of 30 Rock. So think about it. I would like to move it, only because to get someone else to proctor it will be next to impossible. So it's really just me. So let me know your thoughts. We can discuss it next Tuesday if that's okay. All right.
Don't you get free food in jury duty?
No. So in this, we got a letter about that, and they're going to give us a per diem. Woohoo! But all the vending machines are closed. The cafeteria is closed because of COVID and stuff. So they want us to bring our own lunch. Well, the bad thing is I normally bring like yogurt, so I don't want to eat hot yogurt. That sounds disgusting. So I could bring really smelly food, and that's how I get out. 3 cloves of garlic, please, on my Subway sandwich. Thank you very much. No, I'm just kidding. Yeah, we'll see. We'll see. All right. Yeah, they give you $50 a day, but then you have to pay for parking, which will probably cost $50 a day if I'm in Cleveland for 8 hours, so whatever. Okay. All right, so 3. That's supposed to be a 3. 3.2, quadratic equations. Functions and models. Have any of you ever been called for jury duty before? No. It's not terrible. I've done it once, and it was a car accident. And the person who was in the accident was claiming that they were hurt, but the thing that did him in was they went out to dinner before they went to the hospital. So I was like, I don't know if you were really in that much pain if you went to Arby's. So, oh well. Okay. So in this section, we only deal with quadratic functions. It's got a little bit of... Oh, wait, am I thinking a section ahead? Yes, I'm thinking a section ahead. So yeah, this section should be 100% review, which is great. We talk about the 4 different ways to solve a quadratic equation. So before we begin, a quadratic equation has a certain format. ax squared plus bx plus c equals 0, where a, b, c are real, and a does not equal 0. When everything is on one side and 0 is on the other, like we have here, that's called standard form. Also, on a side note, if any of you ever use the like raise hand feature, I can't see it, so just I know that I think I had missed one time, so I apologize for that. It's not on purpose. I literally, there's no notification on my end. So just like unmute yourself and let me know. So like I said, there's 4 ways to solve a quadratic equation. Can anyone name one of them?
Is that what the zero property stuff?
Very good.
Or
Yep.
something like that?
The zero product property. Zero product property says that if you multiply 2 things and get 0, then either one of them are 0. Very good. Can anyone else name another one? Number 2 is the hard one. No one really knows the name for it. They've done it. They don't know, so we can skip over that one. How about, here's a clue for number 3. What am I drawing?
Rectangular form?
Nah. I think that look pretty good for freehand. Yeah, I'm completing the square. Then we have a quadratic formula. And the second one is the square root method. And we'll do an example of each one. Oh, hold on, I gotta cheat. Because these are hard to do in my head. Okay. So zero product property, you want to use this guy when your equation will factor nicely. So let's suppose we had 2x squared plus 5x minus 12. We're going to learn later how to look at it and know if you should bother factoring it. But I'm telling you right out, this one factors nicely. So there's a bunch of ways you can factor this one. You can do trial and error, which is not too bad because 2x squared must be like 2x and x. But the 12 is icky because that could be 1 and 12, 3 and 4, 6 and 2. And then you have to worry about signage. Another way to do it is what's called factoring by grouping. To factor by grouping, you take a times c. I'm going to do that off to the side. A times c would be negative 24. And you ask yourself, what are the factors of negative 24 that add up to positive 5? So what multiplies to negative 24 but adds to positive 5?
That 4?
So it'd be 4 and 6, right? But 4 and 6, even with sign changes, won't be 5. 8 and negative 3. 8.
What about 8 and 3?
Oh, yeah, good job. So if we did 8 and negative 3, those multiply to negative 4, negative 24, excuse me, and add to positive 5. So then what you do is instead of 5x, you could write plus 8x minus 3x. So all you did was you split the 5x into two pieces. And the reason you picked these two pieces is because now you can group the first two terms and you can group the last two terms if my software plays along. All right. So if we group the first two and group the last two, if there's a negative on the third sign here, keep it with that term and just sneak in a plus sign. What can you pull out of the first two terms, the 2x squared plus 8x? What's the greatest?
2x.
Very good. And you'd be left with an x plus 4 after you factored that out. And what could you pull out of the second two terms so that you're left with another x plus 4? So what can you take out of negative 3x minus 12? You can take out a minus 3. So notice they both have an x plus 4. And what would be left over would be 2x minus 3. So that would be the factorization in either order. Well, you have a product of two things that give you 0. Then that means either one could be 0. So the first one, we would add 3, divide by 2. We would get 3 halves. Second one, we would subtract 4. We'd get negative 4. So that's the zero product property. Questions on that? Okay. Next up is the square root method. You want to use this if you have a perfect square equaling a number. So for instance, if you had x squared equals k, then x is plus or minus the square root of k. The key thing is that when you square root an equation, you have to include a plus or a minus. So just making this one up. Negative 3 times the quantity x plus 1 squared equals 12. That perfect square needs to be by itself. Negative 3 times the quantity x plus 1 quantity squared is not a perfect square. We need to get rid of that negative 3. You can't distribute the negative 3 through the x plus 1 because the square says exponents before multiplication. So how do we get rid of the negative 3?
You would divide negative 3 on both sides.
Excellent. So now we have a perfect square, namely x plus 1 quantity squared. And on the right, we get negative 4. So we will apply the square root property, which says take the square root of both sides, include a plus or minus. So we'll have x plus 1 is equal to plus or minus the square root of negative 4. But from section 3.1, we learned that the square root of negative 4 is the same thing as 2y. Two I is also what bullies on the playground call a cyclops wearing glasses. I do not apologize for that joke. Well, we need to finish solving for x. We're currently adding 1 to x. How do we finish solving for x?
Subtract the 1.
Subtract the 1. Excellent. When you are bringing a number over and the other thing has a plus or minus, put it in front of the plus or minus. So that would be your answer. X is negative 1 plus or minus 2y. Students tend to forget the square root method, and instead they would like square out the x plus 1, distribute the negative 3, bring the 12 over. That's fine, but in 3 steps we were done. And you would not even begin to start if you did that way. It's not wrong, it's just you're making more work for yourself. So again, if you can get a perfect square equals a number, square root method. Just take the square root of both sides. Next up is completing the square. Ooh. Completing the square, the process has the square root method built in. And we're just going to learn by doing. Oh, first off, we're going to make a problem because I guess I could make one up. I'm making one up. This is going to turn out terribly. All right, suppose we had 2x squared plus, we'll do a nice one, 4x minus 9 equals 0. Wait for it. Wait for it. No. No, we're not doing that. No. I have to sneeze. I apologize. Let's... No, don't do that. Oh, I'll do that. Can I move that there? Oh, I didn't do it. Let's do 4x squared plus 8x minus 9. That's better. He thinks. Okay. To complete the square, there are 2 things that have to happen prior to the actual process of completing the square. You're prepping it. You're prepping the equation. The first thing you have to do is these can actually be done in either order. The first thing that we're going to do is you have to get the variables by themselves. So in this case, I am going to add 9 to both sides. The gap is intentional. So the variables have to be by themselves. The next thing is we need to make the leading coefficient a 1. There's a couple ways to do that. The way we're going to do it is divide everything by 4 in this case. So now we have x squared plus 2x, gap is on purpose, equals 9/4. So leading coefficient of 1, variables by themselves. Now we're ready to complete the square. To complete the square, you take half of the linear coefficient. Half of 2 is 1. and square it. 1 squared is 1. So take half the linear coefficient. Half of 2 is 1. Square it, you get 1. Whatever that number is what you add to both sides. We're going to add 1 to both sides. Upon doing so, you have done what is called, you've completed the square. You've turned the expression on the left, in this case, into a perfect square. X squared plus 2x plus 1 factors as x plus 1 quantity squared. Sometimes, however, it's not obvious how it quickly factors. And the way to quickly factor it is it's always the variable, in this case x, followed by half of that coefficient, then squared. The reason I'm saying that is sometimes that coefficient is ugly. Maybe it's like 1/6. Ugh. Well, then the factorization would be x plus 1/12, because that's half of a sixth quantity squared. So you don't have to sit there and go, okay, what multiplies to 1 and adds to 2? It's already built in. On the right, what is 9/4 plus 1 as an improper fraction? Very good. It's 13/4. Kids these days. Notice now we have the format of a perfect square equals a number. So because of that, we can now employ the square root method, which says take the square root of both sides. So we'll have x plus 1 equals plus or minus the square root of 13/4. Now, if this were calc, you wouldn't clean up the square root of 13/4. We're not in calc yet, so we have to clean up the square root of 13/4. You can take the square root of the numerator and the square root of the denominator. And this one was nice because this just cleans up as the square root of 13 over 2. We don't have to do any rationalization or anything. And then what we had before was to finish solving for x. Since we have x plus 1, we have to subtract 1. And again, put it in front of the plus or minus. If those were like terms, like if that were -1 plus or minus 5, you would clean that up. -1 plus 5, -1 minus 5. But they're not like terms, so we don't do anything special there. Oops. Okay. The last one is the quadratic formula. Please memorize this. It's good for you. It's the broccoli of mathematics. Don't cover it with cheese, though. Then it's not healthy anymore. Just steam it. As a comment, completing the square and quadratic formula will always work. Zero product property only works if it nicely factors. Square root method only works if you have perfect square equals number. But the latter two will always work. So students tend to just go right to quadratic formula, which I can't stop you. That's fine. We're not going to do an example. You can see a video for it. You've had to have seen way too many of these before. So we're just going to skip it. But we are going to talk about this thing, b squared minus 4ac. Notice that's tucked underneath the radical. This expression is called the discriminant. Oh, and I can't spell it. There's an N in there somewhere. Hate the name. We should modernize it. Let's just call it Taco Jones. So Taco Jones here will tell you what type of answers to expect for your quadratic equation. And there's three things. If b squared minus 4ac is a positive number, so the thing underneath the radical is a positive, then you'll have two real unique solutions. SOL apostrophe N is shorthand for solutions. If the thing underneath the radical is equal to 0, then you'll have one real solution. And if the thing underneath the radical is negative, what type of answers will you have? So the thing underneath the square, they're not real. What are they?
The imaginary number.
Imaginary numbers. Very good. You'll have two, and let's be very specific, complex conjugate solutions. So a plus bi, a minus bi. So just making this up. We're not going to solve it. But here we got a to be 5, b to be negative 3, and c to be 7. So you would probably do, well, you would do b squared minus 4 times a times c. I don't know. What is that? 9 minus 140? So this means we should expect two imaginary solutions when we solve that equation. And that tells us another thing too. Because we should expect imaginary, we shouldn't bother factoring it. We should probably go right to completing the square or quadratic formula. So this one, ew. Okay. Questions on the 4 ways to solve a quadratic equation. All right. Muy bien. Okay, that's 3-2. 3-3 in 24 minutes? Wait, how long did we go to? 7:20? No. 7:25? Oh. This is going to be tough. I'm going to go drink 4 espressos. I'll be right back. Okay. All right. Boop, 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 boop. All right. 3.3 is graphs of quadratic functions. Pretend that's actually what that says. Okay. There's two formats of the function you'll see in this section. You'll see what I call HK format, which has the form a times the quantity x minus h squared plus k. And you'll have the other format, which is ABC format, ax squared plus bx plus c. They both have the same a value. That's the only letter that's the same. So let's start with A. A, for both of them, in fact, I'm going to erase this line here because it's the same thing. When A is positive, the graph is an open, we would say opens up. When A is negative, the graph opens down. So remember, the quadratic function is a U-shaped graph called a parabola. And for it to be a function, it can only open up or down. The terminology opening up, opening down is only for quadratics. In calculus, you're going to learn the word concave, which is for any function. And you don't have to write this down, but like here, notice this looks like it's opening up. We would call that concave up. And then notice this opens down. You would say concave down, blah, blah, blah. You can't say opening up, opening down if it's not a quadratic. All right. Now, if it opens up, notice it has a lowest point. And if it opens down, notice it has a highest point. And that point is called, regardless if it opens up or down, is called the vertex. So the vertex could be the minimal or the maximum point. If you remember the phrase relative min, relative max, it's like that. However, when you are in HK format, the vertex is very nice to find. It's literally h comma k. So you can just look at it and go, I know what the vertex is. When you are in ABC format, the vertex is more exciting to find. You need a formula. The formula is going to look cray-cray, but let's explain what's going on. The x-coordinate of the vertex is given by negative b over 2a. The y-coordinate of the vertex is given by f of negative b over 2a. When you are in ABC format and you need to find the vertex, really all you need to memorize is the x-coordinate, negative b over 2a. So definitely have that in your wheelhouse for this section and moving forward. The y-coordinate looks scary, but all the y-coordinate is saying is put in the x-coordinate back into the function. So if you got the x-coordinate of the vertex to be 5, then find f of 5. That's all that says in English. Okay. And those are the two huge things for this kind of problem. Let me scroll the section real quick. So let's do this. Let me make up a problem. I'll make up two problems. Click here. This comes back. So let's suppose we had the function, I don't know, -3 x plus 2 squared minus 5. And notice that's in HK format. Let's answer a bunch of questions on it. Let's talk about the vertex. So be careful. The format is x minus h. We have x plus 2. What is our h?
Wouldn't it be -2?
Excellent, because this is really x minus -2. X minus h. Good. And then the format says plus k. We have -5. Where's our, what's our k value?
The 3?
Careful. So
I mean,
it's h comma k.
oh, that's the okay, so it's +5.
It's not +5 because format
Plus
says
-5.
There you go, plus k. So this is plus -5. So -5. Good. Does this function open up or down?
Wouldn't it be down
Very good.
because it's negative?
Excellent. And specifically, a is -3, which is a negative number. Good. So we have in our heads, hopefully, an idea of the graph. Because it opens down, the vertex is the highest point, and that's at -2, -5, and it just goes down from there. Okay, so keep that in mind. Domain. A quadratic function is a type of polynomial function. What's the domain of every polynomial function?
All real numbers.
All real numbers. And if you forget that, think about, are there any radicals? No. Are there any logarithms? No. Are there any fractions? No. Domain's all reals. Now, we don't normally ask this one, but we can here because we have an idea of the graph. What's the range? So we have a parabola that opens down, but the highest point is -2, -5. So what are the possible y values?
Would it be -infinity to -5?
Do we include the -5?
Yes.
Yes, we do. Very good. Will this graph have x-intercepts?
No.
No. Very good. The vertex is below the x-axis. The graph opens down, which means the graph is never touching the x-axis. So, none. Oh well. Will this graph have a y-intercept?
-5.
Careful, this one's tricky. So, K is not like C. If I had ABC format and C was a -5, yeah, the y-intercept is -5. Unfortunately, we have to go to, well, y-intercept is a point, so it can't be infinity. We just have to go back to the definition, and we'd have to put in 0 in for x. So if we put in 0 in for x, 0 plus 2 is 2, 2 squared is 4, times -3 is -12, minus 5 more is -17. So 0, -17. Ugh. So that's the other big difference. The vertex is very easy to find in HK format, harder to find for ABC. The y-intercept is easy to find for ABC format, not for HK. It's a little more complicated. Very good. And if you had to sketch a graph, you could rely on what we did in chapter 1, where, and we already said this, the H says left or right movement, in this case left, -2. K says up or down movement, in this case down. And the A says we're going to be opening down. And it's going to be a little bit thinner because 3 is bigger than 1. So if you had to sketch a graph. Okay. Now, we could ask those same exact questions for the ABC format. I'm pretty sure there's a video for that, so I'll have you watch that. What's more important is an application of it, which we can totally knock out in 7 minutes. So let's do an application of ABC format. Click. Let's suppose, I don't know, suppose you have 120 feet of fence and want to build 3 adjacent rectangular pens next to, I don't know, we normally do it like a barn or a river, so a flooded barn. Let's just combine the two. Flooded barn. All right. What dimensions would maximize the area? Don't worry about the animals. You gave them all floaties before it flooded, so they're fine. So here's the barn. And I think we had this drawing earlier. We need 3 adjacent rectangular pens that are, oh, I forgot to write it in the problem. The side next to the barn does not receive fencing. We should write that. The side next to the barn does not receive fencing. That's what that says. I'm way too lazy. So if we wanted 3 adjacent rectangular pens next to the barn, the drawing's going to look something like this. And we need a function for its area. What is the formula for the area of a rectangle?
It'll be like times 2.
Excellent. So for our drawing, this would be the width, and this would be the length. The problem is we have 2 variables. We don't know how to maximize with 2 variables. You don't learn how to do that until Calculus 3. From now until then, you have to learn how to write it as 1 variable. Well, give me an equation that relates the L and the W and the 120, because the 120 represents perimeter.
Wouldn't you have to do 120? Did you say the perimeter or the area?
The perimeter.
Okay, so it'll be 2L plus 2W. Oh yeah, that's right. 120 equals 2L plus 2W.
Well, do we have two L's?
No, we don't actually.
So we just have one L. And how many W's do we have?
Wouldn't it be 2 because of the other side? Or would it just be
One,
that
2, 3,
1, 2, 3, 4.
4. So L plus 4W, and it doesn't matter where the 120 is, on the left or the right, doesn't matter. Okay. So this one was a little tricky because only one L due to the text that we have here that everyone can totally read. And then we have 4 W's because of the breaking up into 3 adjacent pens. Okay, notice we could solve for L here by subtracting 4W from both sides. And now that means instead of the L, we can write 120 minus 4W. If I distribute the W through, I get negative 4W squared plus 120W. Notice this is an ABC format. Comment 1. Comment 2, we're trying to maximize the area. If you are ever trying to maximize or minimize a quadratic function, that means where's the vertex? Since we're in ABC format and we're trying to find the vertex, that means we need negative b over 2a, f of negative b over 2a. Our b is 120. Our a is negative 4. We're almost done. Negative 120 over 2 times negative 4. Don't tell me! 60. I think that's 15. So when the width is 15 feet, that would maximize the area. We could find the corresponding length by putting in the width here. And you would get 60. So you should build it 60 feet long by 15 feet wide, so 15 feet sections. And if the question was, what's the maximum area, you could do 60 times 15, whatever that number is, 900, I think. Or you can put, you can find a of 15 by putting in 15 into the function. But the big, huge takeaway is if you have a quadratic function and you're trying to maximize or minimize, in all these word problems, that just says, where's the vertex? This style of question, definitely on your midterm, definitely on the final. And the reason being is because in Calc 1, you'll have a whole chapter on optimization. That's what that falls under. Optimization is a humongous topic in Calc, but also in real life. Think about it. Water bottles have changed drastically over the years. They used to be very thick, and then the people are like, "Hey, we can make this hold the same volume and use less plastic. Saves us money, saves the environment. Let's do it." And that was based on a little bit of optimization. So huge financial implications of knowing how to optimize a function. All right, we did it. Only 1 minute over this time. Hooray! So again, next week, please let me know what you think about the midterm. As always, let me know if you have questions. Yeah, have a great day or evening. Go get your orange chicken. He's probably eating it now. He doesn't have his camera on anymore. Shame. Read us your fortune cookie later. Thanks. All right. Bye.